All right, hey everyone, this is video number 4 in a 5-part series. In this video, we're going to talk about wire sizing, some code stuff, and then we're going to take the inverter off the wall. I want to talk a little bit about what we're looking at inside of it, and then we'll hook it up to the batteries here and actually turn it on and get everything powered up. So if you're the first time watching this video, if you didn't watch the first 3, we're basically talking about inverters and batteries and kind of a base level of knowledge of what you want to know about inverters and batteries if you're going down the road or thinking about going down the road of installing your own inverter, or maybe paying somebody to install a system for you to give you that base level of knowledge. So video number 1 was components and concepts. Video number 2 was calculating your watts. And then video 3, we did kind of parallel versus series and the benefits of each over the other, and pros and cons, kind of weighed some of that to each other. We're going to do this video I just talked about, and then video 5 is going to be, I want to do 3 different types of systems, and that's going to branch off and talk about some other stuff. But we're going to do a kind of a very inexpensive system, a medium type system, which is like this, and I want to go over some reasons why you might consider a system like this, which I think fits about 80% of the people out there. You could go up or down a little, but we'll talk about that. And then a really high dollar system. If you got deep pockets, money's no object, throw caution to the wind, and you want to spend 10, 15, 20 grand on a system, and getting into like an ecosystem with the Victron you see behind me and all of their stuff and batteries and all that. We'll talk about that, and I'll throw some numbers out there for pricing, and that's current as of January 2022. And yeah, so let's jump into it with this one. Let's talk about wire sizing first. We mentioned earlier that with when you go series, your wiring becomes smaller, and so I'm a fan of this silicon-based wiring. We actually sell it, which is why I'm a fan of it, because I ordered 1,800 of these things so we could sell them, because this is what I like to use. So this is called OFC. It's OFC, oxygen-free copper. Sorry, I almost skipped that one. Oxygen-free copper. It's 99.9% pure copper, but you'll see it looks silver. The silver is a tin coating on it. The tin coating gives it a marine grade, so you can actually use it in high moisture environments as well as regular, dry environments. But it is superior in almost every way to some of the other wires you're going to see out there. The silicone coating, you see, makes it, one, super flexible. It also gives it a much higher heat resistance. So you can go up to 200 C on this versus a PVC jacket, which are typically 105 degrees Celsius. 105 is about 200 Fahrenheit. 200 Celsius is about 396 Fahrenheit. So those are your temperature differences there. This is a 5,000 count strand on our 2 AWG size cable. So you got 5,000 strands. I mean, you can't even see it, but I'm holding I'm holding 3 right here. You can't even see that on the camera probably. It's angel hair fine, which gives it that maximum kind of flexibility there. You can't do this. If this was a solid core copper cable, you'd be bending it like this. They get really hard to handle. These make it easy so that when you want to like go around a bend and you got to keep this in a certain direction, if you ever get a solid core copper, or one that has like 3 strands in it, it's extremely difficult to maneuver around. These are not. This also has a tin to copper lug. So sometimes people mistake the tin on these as some kind of an inferior lug because it's not copper colored. But internally, these are pure copper. This is a pure copper lug, but again, it's tinned with tin so that it's marine grade, so it holds up in harsher environments, whereas copper will oxidize, corrode in a moist environment. This is much more resistant to that. And then finally, it has the polyethylene, which is heat shrink. And I'm not sure if you can see that, but it also has the adhesive lining inside of it. So when the heat shrink is melted down, what happens is that glue, that adhesive inside, gets very malleable, and it fills in all those cracks and crevices inside of there, making these wires extremely waterproof, extremely corrosion resistant, flexible. Like I'm a huge fan of these. That's why we bought so many of them, and we sell them. But there's some other options out there, things to watch out for. Specifically, keep an eye out for CCA. It's called copper clad aluminum. You'll see a lot of that on Amazon. Copper clad aluminum means it's aluminum cord, which means the inside of each strand of wire is aluminum, and then they put tin copper on the outside. It's not as good. It's not nearly as good as this stuff. I've seen by some measures, they consider it about 30% of what pure copper equates to. So again, in the line of I'm trying to arm you with information so you can go make your own educated decisions and maybe go dig more down these rabbit holes. Go look at copper wiring. I laugh because There is so much to learn about just the different types of wires out there. THHN, silicone, CCA, OFC. Residential codes require different types of wires. Are you going to use solid cores better for AC, for high demands? You can go down a rabbit hole with that. But for RVs, sailboats, off-grid type solutions, this stuff right here is pretty much a pretty good go-to type cable. It's fairly inexpensive and works in most situations. All right, enough about the wiring. So I mentioned code there briefly. I want to talk about the code just a little bit. So in the U.S., almost all the states follow. It's ICC, International something committee. Look up ICC codes for building codes for houses. That's what most of the U.S. runs on. The I stands for international, but the U.S. is pretty much one of the only countries that uses it, from what I understand and what I've read on the interwebs. Except for California, Florida, Michigan, and New York. I think they are the 4 states in the U.S. that all have their own rules. Point being, going down rabbit holes again, go look for your state, city, municipality. If you're doing this for a residential purpose, if you want to put an inverter in your home and you don't want to go through a solar installer, you want to save money, you're probably governed by code, and while you could circumvent that code and not follow the code and do whatever the heck you want, the issue is going to be when you go to sell your home and an inspector comes in and says, none of this stuff's up to code. You're going to be backpedaling trying to get it up to code. So just take that into account. Think about that if you're considering trying to put this in your home, and at a minimum, maybe just get a licensed installer to come tell you this is what you need to do to pass code, and maybe they can do it for a consult fee or something like that. Okay, RVs, tiny homes, anything with wheels is not considered, does not have to be up to a residential code. They're DIY. You can do basically whatever you want with them. Because they have wheels and they're mobile, you're not what they call occupy. You're not occupying them, you're camping in them. So if you occupy a home, it has to be up to code. So even though you may be full-time, it has the ability to move, and so you're not subjected to those codes. The only time it's going to get you if you're like have some gross, Frankenstein wiring mess and stuff short-circuiting is again when you go to sell it and somebody comes in and sees it, or they get an inspector, maybe an RV inspector or somebody to look at it, and they say, this is unsafe, then you're going to have issues. So just know that the RV industry and tiny homes, that kind of stuff, bus conversions, van conversions, they're completely unregulated. There are no rules really surrounding them. Lastly is going to be sailboats. That is typically, there's a thing called ABYC, American Boat and Yachting Council or Consortium. They publish some pretty good, it's a pretty extensive library of requirements for boats in their electrical section. They have some pretty unique rules for marine environments, like having a fuse within, I think it's 4 inches of a battery terminal and stuff like that. And those are for safety reasons on boats because electricity around water is so much more dangerous. So maybe go look at the ABYC, rules, regulations, or however they word their code, and check that out before you go down that rabbit hole. The only other thing would be utility trailers that I kind of mentioned in the first video, but again, that falls under, it's got wheels, it's unregulated, so I won't dig on that anymore. All right, so that's wiring sizes and codes. I thought that would be worth throwing out there if you want to go down those rabbit holes of information and searching the interwebs for more on that. At least now you know what you need to be thinking about. All right, we're going to hook these up into the system now. We're going to get it powered on, and I'm going to kind of demonstrate it running a space heater and kind of talk about a couple of things here real quick. I'm also going to take this off the wall first before we put it in series. I want to take that off, lay it down, set the camera up so you can see the bottom of it, and we'll talk through some stuff real quick. It's not too heavy. So. All right, so this is the bottom of the inverter. I just wanted to do this to kind of point out the fact that it's not as complicated as a lot of people think. You get a little bit maybe anxious when somebody's like, oh, let's go hook up an inverter. You're like, oh my God, that's electricity and it's crazy and I'm not touching that. But if you break it down into the simple components and you follow a pretty well-established order of operations, you'll be perfectly safe. But on the bottom, you can see here we have our AC input. So I have that just simply hooked up to your typical wall thing, and this is just for an example kind of setup today. Normally this would be to like a 30 amp plug on the side of a camper, or maybe a 50 amp plug on the side of a camper. and or an sailboat or something like that, and then that would be the wires coming directly into here. I'm not sure if you can see into here very well, but we'll go in. So you can see the connectors here, and I really like the Grow Watt. You're going to hear me talk a lot about positive things about Grow Watt. They've done a pretty darn good job with how this is built. So down here you can see this is an input circuit breaker right here. So it's a 40 amp, and you can see that inside. It's a 40 amp circuit breaker, so that protects this line. And then on this one on the bottom here, that's the output. So that's the one that comes over here. Follow this 30 amp gray wire and comes up, and it is not protected. There's no circuit breaker on it right now, but again, this is just for demonstrations. Normally that would go to a circuit breaker. What else do we got going on down here? We have a Wi-Fi USB plug here, and we're going to hook that up later and talk about that a little more. There's also a USB plug here, and that's for firmware update, which I've already ran the firmware update on this, and that was pretty easy, pretty intuitive. Let me put this back up here. So the USB, it took about 15 minutes to do the firmware update. Downloading it was pretty simple, and no issues there. The BMS plug and the RS485 plug, these are for protocols where you can talk to other equipment. I've not gone too deep down that rabbit hole except to talk about it on forums a little bit, and Grow Watt has not published what their comms protocols are yet, so that's going to take some more exploring and testing in the future. Should be pretty neat though. Down here you got a parallel setup, so if you wanted, you connect these wires to another unit like the one we have on the wall over here, and you could put two of these in parallel to either double your capacity or to do split phase operations, which is beyond the scope of these videos, but just know split phase means you can run really high powered stuff like dryers. If you wanted to put a residential dryer in the back of something like a toy hauler, you could put these in parallel, and you could run split phase power supplies for each side of a breaker panel, and you could run really heavy load equipment type stuff. But that's a little beyond the scope of this video. I'm not going to belabor that one too much. The other thing you have here is this is what's called a normally closed or normally open kind of relay switch. So if you wanted to put something on here that could trigger an action inside of the Grow Watt, there's the ability to do that. And what I mean by that is if your generator gasoline supply had a relay switch on it, you could connect that to here, and when your gas gets low on your generator and your RV, it would basically trip a signal inside of here and tell the inverter to turn off. So you could have your inverter shut down because your gas got too low in your generator, if it's available. So there's options there for that, and normally closed and normally open, I won't get into that. They're just electrical terms on whether or not how the relay is in a normal state. Okay, of course, an on-off switch over here. To turn these on and off, this one specifically, you have to have a battery connected, so we'll get there in a minute. And speaking of that, these are battery cables, so you got a positive and a negative going in, and I'll show you the inside, what that looks like in here. So they got some pretty decent looking terminals in there, negative, positive. And then the last is the PV input. PV stands for photovoltaic, and then that just plugs in right here. You would put a positive and a negative on there. So the way this would work typically in a normal setup and how we're going to use it today is that the battery power comes into here, and then the inverter turns that power into AC power, alternating current, or house power, and that's going to go back out the gray line. And then we're going to plug this line in like we're plugging into shore power in an RV park or a marina. We're going to plug this into the wall, and then that power is going to come in on this black line into the inverter and then pass through. It's called a pass-through feature, where then that power comes back out the gray line and goes back up. It will also simultaneously, the charger inside of this inverter will begin sending electrons back down the cable here into the battery. So simultaneously passing through AC voltage while charging the batteries. That's what will be happening and simulating us getting back on shore power. So that's kind of what we're going to be doing here. If you look in here, this really isn't that complicated. Most of this stuff you don't need to ever mess with. You need the input, you need the output, you need a positive, a negative, and maybe the solar panel plugs, and that's really it down here. The wiring, it's not terribly complicated. You can see this is just a back this off kind of screw, and then you screw it back down to tighten it in. It's a little tricky getting these cables in here because it's kind of stiff wire, but it wasn't terribly hard. I mean, it took maybe a couple of minutes. So that's kind of what you're looking at inside of these things. These were just little bolts, so nothing too rocket sciencey there. And then these are also just screws, you know, righty-tighty, lefty-loosey. Stick the wire in. There's a little bit to stripping wires and stuff, but again, nothing too complicated. Okay, so now we're going to get it back on the wall, and we're going to get the batteries hooked up in a series configuration. And back down. Let's see, one thing I recommend doing when you're hooking these up, there are capacitors inside of the inverter that can absorb a really large amount of electricity very quickly. And so if you put a resistor, and you can just do this by touching it to it with your finger, you put a resistor on here when you first go to connect it up, and you just kind of have to, you can't see it, but there's a little tiny spark there. And so what it's doing is it's filling those capacitors in there. You really only have to do it for about 2 seconds, and then you're good to go. You can put this on and you don't get those giant sparks that you would get otherwise. And so I could show you on this one, there's a big black mark on there because I forgot to do that once. And that's what results is black marks and flying metal. And that's why you always want to wear glasses when you're doing this, safety glasses, which I was wearing earlier and I'm not wearing now. But typically I'm almost always wearing safety glasses when I'm doing this. Okay, let's get it turned on. We are hooked up in a 48 volt configuration. We have our grow watt there. This is we're going to pretend this is our shore power, like we're hooking up into an RV park or something like that. But for now, we're just going to flip the power on. And it's going to power up nicely. Okay, it has switched on. I think it's ready to go. Now we're going to put a load on it. So let's get a space heater and check some stuff out here. First, let's pull up that app again. So now we can see it's discharging at 0.85 amps. This is just battery number 4 here. So what I like to normally do is say if this is consuming 1 amp on this battery, then we're consuming 1 amp across all 4 at 48 volts. And so 48 volts times 1 amp means we're burning probably about 48 watts, 48 to 50 watts, just powering the inverter, which isn't unusual. That's probably about normal. It's kind of, I mean, long term, when you think about it, it is kind of significant. If you're burning 50 watts for 10 hours, so say overnight you turn everything off but the inverter's still running, you're looking at still burning off 500 watts of electricity just to keep the inverter running. So going back to our sizing and using and calculating your watts, that needs to be taken into account because we had 650 watts for the day. Remember that? Well, 10 hours, there's another 500 watts. Your bank needs to be sized accordingly. Solar panels need to be accounted for and all that kind of stuff. So it takes 50 watts per hour just to run the inverter. Let's go ahead and hook up a space heater. And again, normally you would want a circuit breaker panel or a breaker panel in the mix so that you don't accidentally burn up a wire. This is a very controlled environment. I'm in a very short distance runs. I'm not terribly worried about it here. So I don't know if you can see that now, but now it says it's burning 20, or it's pulling 20 amps of power off. 240 watts on this battery means across all of them is right around 1,000 watts of power being consumed. It's coming down a little bit, so we'll go with maybe like 900 watts right now. So pretty neat, right? So now let's see what happens. We get to a park and we're going to plug into shore power. You can hear it beep. It just identified that, hey, we've got AC power available or shore power available. And it should go into a pass-through function, which you can see on the screen, and I'll get a screenshot of that here in a second. But it's showing a grid symbol over there, a power pole, a telephone pole, and that's connected now doing pass-through. And so now the charging, it just lit up and saying that the power is going through the inverter and charging the batteries, and we can see that on the screen now. The charging's coming up. Let's see if we can get that on screen good. It's slowly ramping up the charging on here. 8 amps, 9 amps, 10 amps, 11, and it's going to go up to 20 amps. And if we leave it like this, eventually we will we'll pop the breaker on the silver extension bar thing over here. I did it earlier today. So there you go. It's pushing 20 amps or 265 watts per battery. A total of about 1,100 watts is pushing into the battery while simultaneously feeding power to our space heater here. So that's pretty cool. When you grab onto shore power, it does that automatically. In the next video, we're going to talk about a cheaper kind of setup or more inexpensive kind of setup where you don't have those kinds of options. Some of it is you have to do it manually, but I think you get the idea here. Whew. All right, so that was a lot of information over the last 3 videos plus this one. It was kind of a fire hose of information, just meant to give you that base level of knowledge so that you're armed now with information, and you can either choose to maybe go down the DIY path some more or talk to an installer intelligently so that you know what you're getting for your money and what they're offering you and why maybe they're doing certain things that they're going to be doing. All right, I mentioned that we sell this wire, and this is kind of one of our packs that we sell in 6, 12, and 24-inch lengths. We got 4 AWG, 6 AWG, and 8 AWG. And I got a 4,000 watt inverter last week that I'm going to use to kind of put these to the test and compare them to some other products out there on the market. So if you want to see those, make sure you're subscribed down below. Click that bell icon. You'll get notified as soon as we drop those videos, and you'll be in the loop on that. Our next video is going to be video number 5, and that's going to be the low budget, mid budget, and high budget systems, or top tier budget systems. So that video is coming up next. If you like these kinds of videos, please give us a thumbs up down below. Helps us, helps the algorithms, helps other people find these videos that might be looking for them. And if you have comments, post those down below. I'll do my best to answer them. If I can't answer them, I'll point you towards a resource that does answer the question. So with that, yeah, thanks for watching, and we will see you in video number 5.